Hi, welcome back to Statics 1. Today we're going to talk about what are called zero force members. Zero force members. Alright, if you've been following the class, you're probably thinking, I know it's zero force members. It has something to do with two force members. In fact, that's wrong. And if just for point of recalling, a two force member would be one, there's our member. If this were a two force member, it would have only forces on each end. And if it were in equilibrium, the sum of the forces in the x direction equals 0, sum of the forces in the y direction equals 0, sum of the forces in the z direction, and all the moments were equal to 0, then it would turn out that the resultant vector through this thing would line up with the axis of the member. In other words, that would be the resultant vector of these other forces if it was in equilibrium, and these would be of equal and opposite magnitude. And that's two force members. We talked about those. We see these all the time in trusses, and that's why we're able to solve the truss problems that we are. And these members will be in either pure compression or pure tension with no moments on either end. Okay, so that is just kind of for a review. These are two force members. But that's not what we're here to talk about today. What we're here to talk about today are zero force members. Zero force members have zero compression, zero tension. Basically, they're either in zero compression or tension. Well, so they're neither one or the other. Basically, there's no resultant force through them. And they occur in two circumstances. The first of which is if you have a joint. And now we're talking about trusses, which are basically consist of slender members joined at their endpoints. Remember that. And so the first circumstance where you may have a zero force member, if you have a joint with two members. Right, so only two members come into that joint, and there are no external loads. No external loads. Okay, it turns out that would in fact would be a zero force member. Both of the members, in fact, would have a zero force. Let's see if we can come up with an example from our textbook. Write this out. I'll draw it over here. I think I can fit it in. Let's see. So we have a hinge over here, and it comes down like that, like one up here, and one over here. And there's a force on this thing somewhere. We have a force down here. Right, but you see there are two locations in this case where we have zero force members. Remember, a joint with two members and no external load. So where is that occurring? How about here? No, we have 1, 2, 3, 4 members. Not here. How about here? 1, 2, 3 plus. In that case, we actually have a load assigned to it. How about here? Yes, this is the location. So we have two members coming to that joint. Plus, there's no external load assigned here. In other words, if I put a load on here, then these would not be zero force members. But like it is now, they are zero force members. So this will be really useful if you're solving for the compression tension of individual members within a truss. Extremely useful to be able to look at the truss and say, oh, those three members are zero force, and you can just start with at that point, and you're going to have a lot easier time solving the problem. So these ones are zero force. 0 and 0. One other location. Look at it for a second, see if you can find it. Yes, hopefully you did. Here's another joint. 2 members, no external load. So these are 0 force. Here's one, and here's another. And if you look at them, you've already done some of your problems of method of joints, and you begin to look at these, and you'll understand that in fact, if we took away these members, and let's say I just eliminated them, is this thing going to still stand without that in there? In fact, it is. So the way these zero force members are redundant, and that's the typical thing that you'll find, and they're not even really essential to holding up the truss. Although sometimes you'll design a truss, or a truss will be designed, which has zero force members, which they're there because they're adding stability. And maybe they were there because during construction they were useful to have additional members up. And you may also find a situation where you have, not in this case, but you may have like dynamic loads, where the loads are changing over time. And where those members, which are zero force most of the time, or for under one particular set of stresses, may in fact take on stresses under other conditions or other loading conditions, okay? So that was one. There's one other rule for finding these zero force members. And that would be if you have a joint with 3 members. You have a joint with 3 members. No external loads like before. This one has more rules. No external loads. And 2 of these members, 2 of the 3 members are colinear. In other words, they're along a line. And 2, so I'll put a little plus sign here, plus 2 members are colinear. Alright, so let's look at a case where that occurs. Alright, this is an odd looking truss, but here we have like that, like that, like that. Over here, obviously these are kind of artificial circumstances, although they do illustrate something that we do see, that there are, we do have trusses which have zero force members in it. And okay, the truss like that, that's a truss. That's like a simple planar truss. It's rigid because it has 3 elements and it does stand by itself. But we're going to add 2 more members in here. We'll put a joint here, a member here. Okay, so that's, now we have additional, it's consisting of 3 elements instead of 1 element. And in fact, let's look at our rules. Joints with 3 members, no external loads, and 2 members are colinear. So hopefully you can look at this and find there are 2 locations like that. One of them is at this location. So we have a joint here, 1, 2, 3 members coming into it. It's a joint with 3 members. Does it have external loads? No. The only external load would be like if I had an assigned load to it. No. And 2 members are colinear. Yes, this member and that member are colinear because they're along the line. Means that this 3rd member is a zero force member. Zero force member. Now, hopefully you can look at this and find the other situation. It's exactly the same. Again, here's a joint, 1, 2, 3 members. No external loads on that joint, and 2 of those members are colinear. In other words, this member and that member are colinear. So this member here is going to be a zero force member. So zero force. Okay, so now you have these rules for finding the zero force members. So when you're confronted with a problem and you're solving it by method of joints, or what we're going to talk about later, method of sections, one of the first things you should do in looking at a truss is to identify any of these zero force members and automatically assign them a 0 value of compression or tension. And that's going to make it easier to solve these, because then you can solve the other values. You just have less unknowns to solve for. You'll be able to solve the problems more quickly. All right, so that's it, Zero Force members. If you have any questions, send me an email. Otherwise, I will see you in class.